let's talk about how to find the areas of rectangles and triangles. So let's start with the area of a rectangle. You've probably seen this formula before at some point. Area equals length times width. So if I draw a rectangle, 1, 2, 3 by 1, 2, 3, 4, 5, I can draw it just like that. So this is 5 boxes, and that's 3 boxes. The area is a total of 15 boxes. And this is pretty obvious because you can actually count them up and see that there's 15 boxes. However, it works even with you have non-integer numbers. If I do 1, 2, if I have something like this, where this is 3.1 and this is 7.5, I can still calculate the area as 3.1 times 7.5, and I get 23.25 boxes. And that works because you can count them up. There's 1, 2, 3, 4, 5, 6, 7, 14, 21 whole boxes, and then you have to count that's half a box, that's half a box, that's half a box, and then all these little bits add up to the remainder there. That is the easiest formula. Area of a triangle works similarly. You've probably seen this formula before, where area equals base times height over 2, where the base and the height have to meet at a right angle, just like these length and width meet at a right angle here. So you grab your triangle like this one, for instance. You go ahead and measure. This whole side is 101 millimeters, and the height, which you can draw in meeting in a 90-degree angle, is 36 millimeters. So you just go ahead and you say, for this particular lovely triangle, we have that our area equals 36 times 101 divided by 2. We get 1,818. These are both in millimeters, so our units are millimeters squared. So that works all well and good if my triangle is laid out like this. But what happens if I rotate that triangle so it looks like this? So this triangle, I've measured, the base is 77 millimeters, so I know the area is going to be 77 times the height all over 2. But what is the height in this case? Well, the height has to be the full height of this thing. I'm not going to measure this side. That side doesn't work. That doesn't meet at a right angle. Instead, I have to measure the actual height of this thing. How tall is it? So this is pretty easy. If I line it up here on my grid lines, and I'll tape it down, then I just go in here and I can draw a nice little line. And I drew that very poorly, but it doesn't matter. You get the idea. You can measure this here, and we end up with 48 millimeters on that one. So area is 77 times 48 divided by 2, which ends up being 1,848 millimeters squared. So it's not exactly the same as what we got before, 1818 versus 1848. Those are a little bit different. Is it a big difference? Do we think we did something wrong? Well, the difference here is 30 square millimeters. And is 30 significant? Well, 30 out of 1,800 is not that big a deal. If you do the math, we are off by less than 2%. It's around 1.5% difference. So we think our differences here are just due to the way we cut this and measured it with a ruler. If we were more exact or used a computer program, those should end up the same way. So you might have seen this formula before, but why exactly does this work? To answer that question, let's look at a different triangle. Just kidding, let's look at the same triangle again. So we take this triangle that we started with over here. I rotated it, though, for no good reason. And I went ahead and you can snip it like this. Now, when you snip it like that, just bring in this same triangle again, put it down the same way we have over here. Go ahead and snip this, turn these pieces over. So you rearrange them, and you can see now we actually have a rectangle. So base times height over 2 is very much based on length times width. Because when you rearrange these pieces, you can see we have made a rectangle. So the area of this triangle here is half of the total rectangle area. And you can do that with any triangle by cutting it up and putting it together correctly. You could do the same thing here, and you could realize that this all fits into a box with this length and this height. There is another way to find the area of a triangle. There's something called Heron's formula, named after this guy Heron, or hero from ancient Greece. Heron figured out that the area of a triangle is equal to S times S minus A, S minus B, S minus C, all of that square rooted, where S equals A plus B plus C all over 2. And A, B, and C are just the sides of a triangle. So any triangle, if you have sides B, A, and C, you just calculate this S, put all those numbers in the formula, you can get the area. let's go ahead and try it out with a different triangle. Haha, no, it's that same triangle again. So here I went ahead and measured all the lengths here. I have my 101 millimeters I measured before, the 77 I had before, and this 49 I had. So we'll go ahead and calculate S. S equals 49 plus 77 plus 101, all divided by 2, which gives us 113.5 when we put that into a calculator. Now we calculate the area. This takes a second to write it all down, but we get 113.5 times 113.5 minus 49, 113.5 minus 77, and 113.5 minus 101, all of that square rooted. So if you simplify this, you can put this all in your calculator in one step, but if you go through the math, it's going to look something like this. So you can see this formula gave us an answer of 1828 roughly, which coincidentally is just kind of between these two numbers. So they all give us roughly the same story. We can just calculate the area of a triangle according to whichever of these we like best.